request. But let's look at an example where there is a development and test shop. They're developing software and want to test it. So developers have developed some piece of software and testers want to test it. But for testing it, they need an environment. They need a database to be set up. They need application servers. They may need some other software bits to be set up. They can define all of that using topologies and just request for a test environment for this type of software and immediately get that provisioned in the cloud. Okay, so again, it's all about speed and doing it with consistency, right? Typical test configurations are very standard. So they can just do that in a very standardized manner and with great speed. All right? Now, key aspect of most cloud deployments is virtualization, and obviously requirement is also to manage that virtualization, right? Again, in theory, you could build a cloud with physical hardware. Just bring together your hardware into a network and you can do provisioning and so on. But you're not getting the real benefits of flexibility and elasticity, right? And in order to get that, almost 100% of cloud installations today use virtualization. In fact, that's the first step before they even go to cloud, right? Many data centers would have virtualized their environments first and then think about deploying clouds. So managing virtualization is a key aspect of any cloud deployment. Okay. So some of these things go to answering your question about differences between clouds and network. The things which clouds are doing today are way beyond what typical network services used to be, right? So data center and service providers are actually deriving benefits out of things like this: virtualization management, automated provisioning, self-service, and that's really what is differentiating today's clouds from just plain network hosting services. Okay, with all of this wonderful, self-service request provisioning, automated provisioning, and so on, key aspect is usage metering and accounting, right? So again, most cloud systems will build into themselves a mechanism to, monitor usage, do billing, and so on. They're fairly standardized techniques, but very important from a cloud perspective, right? All right, multi-tenancy. I think we just briefly mentioned it a little bit earlier, but in the cloud scenario, multi-tenancy becomes really important. How many of you understand multi-tenancy well? Or shall I just go over that a bit? Okay, let's start with the simpler scenario where one customer or one user is using an application on a single system, right? Not sure if that's out here, but just take a very simple example of one particular user using a set of applications on one system, right? That's a standard single tenant system, right? Now, when we get to the point of, say, let's share the database, right? Because all we really need is one instance of the database. It's powerful enough, my machine is powerful enough, it can serve multiple users. So my same database instance is now starting to serve multiple users, right? It becomes a multi-tenanted database because it's serving multiple tenants, right? Now, going beyond that, multi-tenancy can be applied to almost any aspect of the services, right? Each service can support multiple tenants or multiple users. And the reason why it's important is that it needs to maintain that isolation, right? Now, for example, when a database serves multiple tenants or multiple clients, it's important that it has right policies and the right techniques to keep the data isolated, not have any kind of data sharing or any of those kind of things. So it's very, very important to have that kind of isolation levels built in. In cloud, because you're using a virtualized environment, right? Think about this. On one physical machine, you may be running 5 or 10 or even more virtual machines, depending on the hardware capacity, right? Now, each of those virtual machines could be serving a different customer, right? Each of those virtual machines could be serving different customers. Now, logically, they are all separate, but they are all running on the same physical hardware, right? So the same multi-tenant requirements become applicable there as well, right? So your virtual machines need to support multi-tenant usage, and actually every application or every system in that stack needs to support multi-tenant applications. All right? Any questions on this one? Yes. It almost becomes a necessary condition if you're going to use virtualization. You can certainly, yeah. You could isolate some machines and run them in purely single tenant mode, and still, if you're only going to utilize some other benefits of cloud and not the multi-tenancy ones, you can, right? It can happen without cloud, certainly, right? Databases have been there for a long time where multiple users are accessing them, but in the cloud it becomes slightly a bigger problem, because now you're virtualizing it, and multiple databases, multiple app servers, they're going to be serving multiple customers. Okay, so the problem gets slightly magnified and is almost always there, right? But you're right, it could exist without cloud as well. Okay, a very key element in any cloud implementation is the security and the privacy aspect of things. Again, there's no one answer to this, but it's an important aspect to consider whenever you're thinking about any cloud deployment, right? You'll have to see where, depending on the kind of cloud you're deploying, you want to see what kind of security controls you have and how security is implemented at each of these points, right? You want to look at identity, right? That's one of the first things we will look at. What are the roles? How do I manage user identities? How do I manage roles? Second, around data and information. How well is my data and information protected, right? There was a question earlier about encryption. Do I need to encrypt my data? Is it encrypted on the network? And so on, right? Now, how about applications and processes? Are they secured as well, right? It's not just about user identity and role management, but the applications themselves, are they secure enough? How about the processes, right? Can somebody, inject malicious code into my running process? Is the process secure, right? Obviously, very key element, network, server, and endpoints, right? Because clouds are going to be accessed from potentially multiple locations, and there are going to be multiple access points, you want to make sure that each of those endpoints are secure. Your network layer, your network transport layer, all of those are secure as well. And one element which one must look at is the physical infrastructure, right? Your cloud or any data center is as secure as your physical infrastructure is, right? If somebody has access to your physical machine, your physical data center, and they have a malicious intent, they can't really mess around with it, and very little you can do about it, right? Although there are techniques to prevent that, there are things like, in the hardware there are locks and alerts and all those kind of things. But it's important to consider cloud security from each of these angles. And when you start thinking about each of these, the discussion itself can be fairly detailed for each element here, because there are several aspects of security that can be put in here, both from a tools and technology point of view, as well as some may be just best practices, right? It's possible that everything cannot be done via tools and technology, right? Some of them are just best practices to follow while implementing a certain service or a certain method, okay? Any questions here? We have talked about this a little bit earlier about business process as a service. Really moving beyond the basic of cloud, right? Moving beyond infrastructure, platform, and the software as a service. Where this is going is towards smarter commerce, social business, analytics, optimization, and smarter cities. And now I'm slowly going to move into some of the real, use cases where, companies have been using it, and also within IBM. But that's where the real challenge is today, right? Most of the problems in the infrastructure and platform have been sorted out, or at least are well understood, right? There are well-defined methodologies and mechanisms to deal with the problems here. The interesting part is in the business processes as a service and how the applications themselves get deployed in the cloud. Okay, and those are just some of the areas which are very interesting today. Okay, just one example of how IBM business services are being used, like within IBM. A lot of our marketing organization, for example, right, 35,000 marketers across 6 continents. They run the entire marketing operations out of cloud within IBM, right? And all of their customer interactions and everything is done from within the IBM cloud, and that's set up as a business process as a service, right? There are lots of statistics there. Don't worry about them. But the key point to realize is that the marketeers or the people in the marketing team have really no understanding of how cloud operates. They really don't care about that, right? All they care about is how their marketing processes work on top of that cloud and how they access it, right? So just one example of how it's being used internally. And then, of course, smarter commerce being used across the board to do things like real-time analytics with Cognos, marketing I just mentioned. Also, a lot of things are being done for supply chain optimization, right? Again, all these business services are getting built on top of clouds, and more often than not on private clouds, right? These are things which companies are doing within their enterprise, right? Most companies are running their marketing operations or their analytics or their optimize, except for the social business, right? All the others are being done primarily in the private cloud space, right? The reason I mentioned that the social business there is, it's still a business process as a service which is being used, but just because the nature of the kind of service involved there, it's social, so it's essentially going to be on a public cloud, right? All right, let's quickly look at some of the case studies here, unless there are questions of any of the things we have discussed so far. Okay. This chart actually does not mention cloud anywhere, right? But these are the benefits these companies have seen in their business by moving to a private cloud model. Okay, and don't spend too much time looking at the details into this, but we'll look at the details of some of the other ones. But just to show that companies today are measuring the benefits of cloud not in terms of cost just from the cloud deployment, but actually how it's benefiting their businesses. Transportation companies looking at how it helps them reduce partner integration time, right? Petco looking at how they could increase sales per web visitor and so on, right? So they're looking at business metrics to define how cloud is helping them. Okay. I keep on coming back to this example of development and test, right? Because it's one of the easy ones to explain, and then you can extrapolate it to your situation, right? But in the dev and test one, for example, here we have seen real savings. In the earlier situation where you had a traditional IT system, when you're requesting for resources, either a development team or a test team request for resources, it takes some time for that request to get validated, approved, servers to be built, readiness, and so on, right? When they move to cloud, all of those things have kind of got compressed within a very short time frame, right? So you look at those graphic on the right-hand side, right? Cloud with service management. So from a self-service portal, the user requested for the machines he needed and got provisioned automatically. And they immediately came to know which machines those are, and they can start using them. So if you can see the different colors there, right? The dark blue ones are the automated processes, right? That's helping compress the time for the machines to be made available, right? And that's a significant difference. And if you really see this graphic here, it's going to show where the savings are coming from in a dev test environment. And you can easily apply this to any other environment which may be applicable in your scenarios, right? Yes, you do have to invest initially. We talked about this earlier in terms of cloud implementation or cloud software, managing software and hardware. You might need virtualization, that's the hypervisors there and so on. But then the benefits are really coming in from the time you're saving in the provisioning process, the sysadmin time savings, hardware licenses, and productivity improvements, right? And which is quite significant. And there are customers who have seen real benefits out of using DevTest Cloud in their environments. And again, DevTest by nature is a private cloud, largely, right? Most companies are setting up their own DevTest environments or moving their existing hardware or software infrastructure into a cloud for doing development and test, right? Yes?
The question of trade-off that you put into the accountability part, the costing one, of course, those are invisibility, but nonetheless, do you factor in right now? Because trade-off, because of course you say sort of saving, yes, what are the trade-offs? Because it's always a trade-off when you talk about.
Yeah, trade-off is this. You are investing upfront in this you have to make this investment upfront, right? You're probably going to pay for cloud services to be implemented. You're going to buy.
That's a physical form.
Yes.
Yeah, that's a physical form.
Yes. So this is the trade-off between what you need to invest and what you're going to get back from it.
Yes, but you see the psychological part, the other part, it is always not consummation. So the question is that you say security and so on and whatever, not sharing and so on. I think that there must be also be, a clarification of that part in the sense that this is the thing that you trade off, you compromise upon.
Yeah.
So the question is that the element here is that how in the future that we find that the risk factor here, that what you trade off, you will find that you're still secure, very secure in terms of those are the things that the quantum is going to be.
Yeah. So security is one aspect only, right? But for dev test in a private cloud environment, those factors are not that important, right? And that's where people are seeing real benefits out of this, right? Implementing development and test, even within IBM, right? We have moved thousands of our developers worldwide to internal dev test environment, right? And those issues of security and privacy don't exist within the enterprise.
I do understand
Yeah.
that, but what I'm trying to say is that the invisible part will always be factored in.
Oh yes.
There's no mention at all.
I guess so. I guess that will be part of any transformational move you do, right? Any transformational move you do from your existing setup to the next one.
You know why? The element of governance come into it, transparency come into it.
Yeah, absolutely. They will, right? They will. This is purely looking at the benefits you would derive out of moving to such a system. Now, some of those may be, may not be quantifiable things which you're mentioning, right? That's possible. Yes. Okay. I've kind of used this example earlier, so I won't spend too much time on this. But the only thing I wanted to show from here is that this is again within IBM example. Once you can see all of these elements here, they're kind of reduced in cost. What it's doing is it's creating more money available for new development, right? So our total budgets are fixed, and we can reduce the cost elements here by going cloud or by going into a virtualized setup. We're going to have more money left over, and we have seen those cases there, in terms of actual savings in some development groups. So for certain kind, I guess the message I want to leave you as far as this is concerned is, for certain kind of workloads, especially dev and test and a few others, the ROI case has been proven time and again and is very straightforward, right? For other workloads, ROI case needs to be built out, right? For all of them, it's not a straight one formula fit all kind of thing, right? But for certain well understood workloads, the ROI formulas are very well understood. Okay. Here's another example of how some of the cloud capabilities are being used in a business scenario. In this case, what we call the smart cities operation console. this is integrating several aspects of city management, right? From public safety to traffic to water management, and all of these are available from one single dashboard or console, and city planners and city managers can actually manage all of those aspects of the city from one location. This is yet another instance of a business process being modeled into a cloud kind of service, right? So think about it this way, right? Water management, traffic, and so on, each of these export certain services, right? Each of them have certain services which are essential for their management. And what this operations center is doing is bringing it all of it together in one place, right? So they could all be managed in a consistent manner, right? And these are all being done out of private clouds, right? Here's one example of it: the city hall in Rio de Janeiro, right? They're using the smart cities operations console to do all of the things we talked about earlier, right? Also communication between different agencies, improving response times, and so on, right? So it's one example. Again, going back to dev and test, here's a bank in South Africa, NetBank. They've built their private cloud services using a dev test kind of environment, right? Again, dev test very common, right? Every organization has some development and test, and they have seen their provisioning time reduced to weeks, reduced to minutes from weeks, and configurations are consistent. Test environments are high quality, resulting in higher quality tests, obviously, right? So it's another example of how dev test clouds are being used in a private environment, right? This is Bank of Tokyo Mitsubishi. These guys are using a private cloud, but not for dev test, but for deploying virtual desktops, right? So what they're doing is, they have, I don't know how many, 34,000 employees, right? So some large number of employees spread in multiple locations, giving everybody a separate laptop or some other device. It's very difficult to manage it, and you cannot have consistency across the board. So they're using virtual desktops via a clouds environment. Okay, so this is another very common workload deployed today in private clouds. It's called the desktop cloud. Okay, and they're using it today to actually manage their entire end-to-end end user management and desktop management. Okay. This is again another example of dev and test environment for Nippon Life Insurance. For dev test, really the use case is the same, and just the environments differ in terms of the infrastructure, in terms of kind of things they're developing or testing. But their essential use case is the same. There will be development teams who are going to develop software, and test teams are going to test it. They need similar environments, but at different times. And they need different configurations to test different software configurations. All of them have the same requirement of repeatability. They want consistent environments to be created every time. So again, using a dev test cloud really makes that very consistent at a very high speed for them. This is a slightly different example from the healthcare. Sharp is a healthcare company in San Diego in the US. They are using a private cloud to bring data together, clinical data together from multiple sources, and providing it as a service out of their network to other medical practitioners. So again, it's all about consistency, right? You could have provided this information out of websites, right? Companies have been doing it for some time. There are well-known medical sites providing information out of websites. But this is going a little bit beyond that. It's actually combining information from multiple medical records, medical sources, probably doing some analysis on them, and suggesting course of treatments and so on. So they have some of their own proprietary technology. They mentioned here Care Engine, but they are actually using all of these and then making all of these services available to other practitioners in that area using a private cloud. So I've just put these here to sort of provoke some thoughts in your minds as to you can use cloud for many different things, right? It's not just for dev or test, not just for one type of industry, it's not just for cloud data providers, it can be used in many, many different areas. Yeah, this is a reference we like to talk about a lot. Of course, NATO we're all familiar with. They also have an on-premise cloud for doing their testing and developing network. They're actually building their control command center and so on, and all of that is being done via an on-premise private cloud again. So the reason I like to quote this example is there's probably very few companies or organizations more aware about security than NATO, right? So there are companies like this, organizations like this, who are looking at clouds in a very sincere manner and actually using it, right? They have overcome some of the barriers which are in people's minds about security and so on by deploying the right technologies, by deploying the right best practices and things like that. But these are real examples of companies like this using clouds, right? Okay. And then finally, we do a lot of analytics within IBM. So you can see, consolidated about 20 different product departments using our own Cognos. So huge data sets, a lot of analysis done on within our own private cloud within IBM. So all these technologies we have talked about earlier are not just for external use, but we are actually using them internally as well. And you can see the savings that IBM has derived over the years by moving some of this analysis into a cloud kind of environment. I guess this is the last chart here, just to give you a flavor for where we are set up in terms of cloud. IBM, we do have 7 cloud data centers and 11 cloud labs, one of which I'm part of here in Singapore. And then, of course, we have delivery centers all over. This is the part which I really wanted you to see, that we are using private clouds for all of these aspects, for analytics, for collaboration within our enterprise, for dev test, for desktop as well, for storage, and for business services, right? And for a large part of the organization, they're using the internal cloud in some way, shape, or form, right? And this is the direction not just IBM, many companies are going towards today, even for their internal use, right? All right, so I think that's all I had. It is an opportunity to use the cloud. Are you ready to take advantage of it? I hope I have helped you decipher some of it. I'm sure there will be many more questions, but hope you'll take advantage of some of the technologies available today, right? Thank you. Any questions I can address? Thanks.
I think we still have about 5-10 minutes time. Any questions?
I have a question. It seems to me that cloud computing seems to be a kind of distributed software running over the internet network. I don't know am I right or not?
Okay. So first thing, I'll remove the word internet from there, right? Internet is not necessary to run cloud, right? You could run cloud within your own enterprise, right? We had the discussion earlier about not necessarily having public access to it. You could run a private cloud. You could have the cloud characteristics of cloud within your enterprise. You could get the elasticity. You could get provisioning, self-service, and so on. All of those things, right? Without involving the internet at all, right? So
it seems to be a kind of advanced customizable software.
actually, no. It's actually more than that, right? It's about how much more efficiently can you utilize your existing resources. Let's put it that way. That's probably one-line answer, right? I have a bunch of resources. How efficiently do I utilize them? How speedily do I utilize them?
Like it's a kind of software solution provided by IBM to manage all those resources provisions.
Yes, while I would like to think that way, it's not just IBM though, right?
Yeah.
So,
for example, if our organization like to implement a private clouding of IBM.
Yeah.
So who is in charge of implementing all those solutions, cloud solution? And after the successful implementation, charge of maintaining the daily hardware, software?
Yeah, so that's something one can decide, right? As far as implementing cloud goes, right, we can help you decide what kind of cloud you need, right? How big, small, capacity, and all of those things, right? And can help you configure that. You can bring your applications to run on it, right? Now, once it's running and up and running, you can decide whether you want to manage or maintain it yourself, or you want to give it to a third party to manage or maintain it.
So is that third party the IBM or?
Certainly can be, yeah.
Chris, I have only one question. Follow up to the earlier one.
Yes.
You know why? When you talk about the IBM business suite, now you were saying that you're addressing specific business challenges. I remember asking IBM many years ago when the cloud came in, and I said that look, you have the niche definition, you have the IBM definition, but I think what is most essential in today's complexity, especially when you say that when you talk about the property, it is when you talk about, let's say, a condo, and you say freehold doesn't have freehold, doesn't have leasehold. It is very much time sharing, very much time sharing.
Mm-hmm.
So the question of time sharing and the legal definition is what is not provided all along, because the question is that would IBM come up with a legal definition, which you think that legally all lawyers will concede with this definition, because you know what, we can say maybe we twist and turn, but the question is that there must be, and that's so the legal definition that stands for universally.
Yeah. Today the nature of cloud is that there are many different definitions, obviously, right? There are standards bodies which are trying to define standards around clouds.
Yeah,
IBM is part of that.
Technology definition, but not legal definition.
Well, I don't think courts today are considering clouds, right? So if you get to that, yeah, it will be, right? And at that point there will be legislation and all of those things. Today it will be treated just like a vendor and a user contract. Right? Today, when you sign a contract with any service provider, you sign a contract.
You can't run away from a legal definition.
No, but it will be written the same way as you write today's contract. There's no difference. Today,
I don't agree.
yeah.
I defer that, because you know why? At the end of the day, there will be, because you know why? You go into a legal definition of properties, so there will be definitely a legal definition for it. Not technology, because it's subjective. Because when you go into industry, it's subjective.
Sure.
But when you go to arbitration, it has to be a legal definition.
Right. All I'm saying is that today is governed by the same laws and technologies or the laws and legal framework which governs everything else.
Likewise, because
right?
you know why? We are running away from the point that it is very much time sharing definition, rather than not really in the kind of condo that you say that condo in the cloud, in the sky, and you say that it is freehold, leasehold. Not really, because it is very much timeline.
Mm-hmm.
It's
Okay.
very much timeline, and the timeline is not defined.
Mm-hmm. Okay. All right.
Will your
Yes.
presentation be available because sometimes they're available for links?
I haven't checked on that. Plus, I have to check within IBM this can be published on a web or not. Maybe I can create a version which can be.
A few months back, Amazon Web Services, they had an outage in their cloud.
Yes.
So how is IBM addressing that problem on public clouds?
IBM does not address Amazon problems.
No, I mean in your similar public clouds, because I never worked.
Yeah, so in our own clouds, our clouds are actually built to guarantee certain SLAs, which are much higher than typical public clouds. So in order to guarantee that SLA, there are additional things built into it in terms of resiliency, failover, and so on, which are.
At the hardware data center level.
Oh yeah. So our data center itself is actually, there are I think 6 data centers. That map I showed there. There are 6 data centers which serve our public cloud worldwide. So today you could request for the resources to be specifically assigned from Germany or from US if you wanted to, or you could just take from Singapore.
Duplicate your data.
Yeah, you could do that. But even without you having to do that, IBM has mechanisms for failing over internally and so on. Without that, you can't guarantee SLAs, right? And that's why when a public cloud customer signs on to IBM, they sign a regular contract which defines all of those things.
So how is it different from Amazon public cloud? How is IBM?
Yeah, Amazon's SLA is not a guaranteed SLA, right? It's a best effort basis.
Operational
I don't know Amazon internals.
Okay, because they also have their SLAs within the field many times.
Right. No, I'm saying I'm not in a position to really comment on that, right? Because I don't understand Amazon internals that well, right?
But can you really guarantee an SLA?
We do.
No, I mean, if the server goes down, you can't really guarantee that you'll be 99.99.
Well, all SLAs are in some 99 point.
The EPS,
Yeah.
I'm sure there's an SLA that you guarantee, but it still breaks.
Yeah.
There are multiple factors. I don't think guarantee is.
Well, the way SLA guarantees work is that one, in terms of those percentages, and the other is also how quickly we can bring you back up, right? What kind of support network you have behind it,